Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the fifth of 10 videos in the Operations and Algebraic Thinking grouping. The video is about understanding subtraction as an unknown addend problem. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the standard that this video is based upon follows at the end of the video. In this standard, we want our first graders to understand that a subtraction problem can be restated and thought of as an addition problem with one of the addends or numbers that we're adding will be an unknown. This may not sound clear right now, but hopefully by the end of this video, it'll make sense. So I think it'll be easier to show you this by equation, but actually even going back a step and showing it using the linking cubes or the Unifix cubes. But before I even do that, we need to make sure that the first graders understand these signs, the addition sign or joining together, the subtraction sign or taking away, and then the equal sign, meaning that whatever the value is on this side of the sign is the same value as on this side of the equal sign. So what I have here for an equation or number sense for starters is 10 minus 8 equals some unknown. And we want our first graders to understand that this would mean the same as 8 plus some unknown equals 10. But before we even do this, let's take a look and represent this 10 minus 8 on our number line using the Unifix cubes. So I've started here and I've placed 10 Unifix cubes on the number line. This is what we're starting with. And I'm showing that we removed 8. So 10 minus 8 equals 2. Now, another way we could be saying this is we could be saying 8 plus something equals 10, because we know that 8 plus 2 equals 10. Using the same numbers but switching them around, I'm now showing the subtraction problem of 10 minus 2 equals some number. So 10 take away 2 or 2 from 10 equals some unknown. So we're starting with 10. We're taking away or we're subtracting 2. And when I do that, I'm left with 8. So another way of saying this would be taking the subtraction problem and turning it into an addition problem with an unknown. So it's 2 plus something is going to be equal to 10. And what we're showing here is that we would be able to solve this and be able to say that 2 plus 8 would be equal to 10. So what we've created here using the numbers 2, 8, and 10 are what the first graders may be calling their fact family. So these are creating equations, addition equations and subtraction equations that are related to one another. So from the three numbers, we can create two addition equations and two subtraction equations. So we have the related equations of 10 minus 8 equals 2, 8 plus 2 equals 10, 10 minus 2 equals 8, and 2 plus 8 equals 10. Now, there are some other equations that can be created, but they would not be equal. So we want to make sure that your first grader doesn't try to set up equations like 2 minus 10 equals 8 or 8 minus 10 equals 2. If they're trying to do that, it just means they don't have that understanding yet. And what you might need to do is go back to be using the manipulatives or drawings to show them more concretely the relationship between the addition and subtraction of the three numbers that you're creating the fact families for. Some first graders may use this triangle to help them come up with the fact family. So they might be placing the 10 at the top and the 2 and the 8, and then they can see that they start with 10 and they subtract 2, they're going to get 8. Or if they start with 10 and they subtract 8, they're going to get 2. And for addition, if they add 2 plus 8 equals 10, or using the commutative property, 8 plus 2 would be equal to 10. Other students may use something that's called part whole. So if we look here, we have 3 boxes. On the top, we have 2 parts. We have the 8 and the 10. And when we put the 2 parts together, when we add them, when we join them, 8 plus 2 would be equal to 10. And as far as if we subtract or we break apart and we start with 10 or the whole of 10, and make sure your students, your first graders understand when we're saying the whole, part whole, we're not talking about a whole. We're not talking about a HOLE like the hole in a donut, but we're talking about the WHOLE, the whole, the entire amount. So you can make sure that your first grader is clear on that. So the whole, the entire amount, the 10, when we have 10 and we take one of the parts away, 10 minus 2, it equals 8. And then when we also start with the whole of 10 and we take 8 away, we are left with 2. And sometimes you'll see this part whole diagram and the whole may be on the top and the 2 parts will be on the bottom. Both represent the exact same problem. So once your first grader has an understanding of these fact families, we can try to see using a word problem if your first grader would be able to come up with a couple of different equations, for instance, in this word problem. So Jamal had 10 balloons, 8 flew away. How many does he have? So writing this as a subtraction equation, we'd want the first grader to be able to say 10, because that's what Jamal is starting with. So when we write a subtraction problem, this first number is going to be our starting point. 10 minus 8 equals how many? So looking at it in terms of our part whole, the whole is 10. One of the parts is 8, and we're looking for the other part. So if we want the first grader to write this as an addition problem, it will be an addition problem with one of the addends being unknown, because 8 is one of the parts. 8 flew away. The other part is what we don't know. So it's 8 plus some number of balloons will be equal to our whole or equal to our total. And the student can do this. What they might find is, yes, they can write this as 10 minus 8 equals something, but they're not sure of the 10 minus 8. And they can write this as 8 plus how many? Then they may be able to more quickly solve this and know that 8 plus 2 is equal to 10. Conversely, a student may first come up with an addition problem to solve a word problem, and then they might realize that it might be easier for them to use a subtraction problem. So for instance, In this example, Jamal wants to give his sister 10 balloons. If he has 2 balloons, how many more does he need to buy? So we may first think of this as, well, we have 2 balloons, so 2 plus some missing addend here. 2 plus something is equal to 10, our part, whole. But instead of trying to solve the problem this way, we may want to look at it as, well, we know that we want to give the sister 10 balloons. We have 2 already. That's one of the parts. What's the other part? What's the other part? How many do we need to buy? So we can take this addition equation, and once we're comfortable using our fact families and our relationship between addition and subtraction, we can turn this into 10 minus 2 equals something. So if we're starting with 10 and we subtract our addend of 2, the other addend, or in this case here, the answer to our subtraction problem of 10 minus 2 will be 8. If you're interested, here is the complete standard that this video, Understanding Subtraction as an Unknown Addend Problem, is based upon. Understand subtraction as an unknown addend problem. For example, subtract 10 minus 8 by finding the number that makes 10 when added to 8.